a test user admin test with an invalid email suddenly appeared in staging, triggering a security rollback. The root cause, a dependency override that was never cleared, leaking a fake database session into production routes. Let's break down FastAPI testing with PyTest and TestClient, how it works, and the exact mistake behind that failure. FastAPI's TestClient lets you simulate HTTP requests without a real server. Combined with PyTest, you get fast, isolated tests that catch bugs before they hit production. TestClient wraps Starlet's TestClient, giving you a lightweight HTTP client that speaks ASGI directly. You send requests, inspect responses, and validate behavior in milliseconds. It's unit-level testing of your root handlers, middleware, and dependency injection graph in isolation. TestClient works by constructing a raw ASGI scope from your request parameters and feeding it directly into your FastAPI application's ASGI handler. Dependency injection, middleware, exception handlers, and even background tasks execute exactly as they would in production. The TestClient allows you to make standard HTTP calls and receive a full response object. Most tutorials show TestClient app as a one-liner, but in production you'll want a fixture that manages the client's lifecycle. Here's a basic test. We create a FastAPI app, define a health check endpoint, and use a PyTest fixture to create the TestClient inside a with block. Then we write tests that assert status codes and response JSON. If you create the TestClient outside a with block, startup and shutdown events don't run. This means database connections or other lifespan initializations are skipped, causing flaky tests. Real-world testing requires bypassing side effects like sending emails or writing to a production database. App.Dependency Overrides is a dictionary where the key is your original dependency and the value is your mock or fake version. Here we override the get DB dependency with a mock that returns a fake session. After the test, we clear the overrides to prevent cross-test pollution. Dependency overrides are stored on the global app object. If you forget to clear them, test B will run with test A's overrides, causing false positives or false negatives. For endpoints that require authentication, override the dependency that extracts the current user. This isolates your root logic from the auth provider and speeds up tests significantly. We override getCurrentUser with a lambda that returns a test user with a specific role. This lets us test authorization logic without generating real tokens. For routes that read-write to a database, use an in-memory SQLite database. This gives you real SQL semantics without the latency or contamination of a shared database. This fixture creates a fresh SQLite in-memory database, creates all tables, yields a session, and then drops the tables after the test. Each test gets a clean slate. Your application likely has custom exception handlers that return structured error responses. Testing these handlers is critical. If they break, clients see unexpected response shapes. We test both custom and unhandled exceptions. The custom handler returns a structured JSON response, while unhandled exceptions should return a generic 500 without stack traces. If you write a TestClient in every test function, you're doing it wrong. Define a fixture that builds your app, applies overrides, and returns a client. Every test function that needs it just declares it as a parameter. This fixture sets up overrides and returns a TestClient. Put shared fixtures in a conftest. Py at the root of your test directory, PyTest auto-discovers them. One test per valid input is fine for a demo. In production, you need coverage for the ugly stuff, missing fields, wrong types, out-of-range values. Parametrize generates a separate test for each case. Here we test invalid user creation with multiple inputs. Each tuple becomes a separate test case, so when one fails, you know exactly which input broke it. Unit tests with TestClient catch logic bugs, but they can't tell you if your middleware, background tasks, and database actually play nice together. Integration tests validate the entire request lifecycle. This integration test uses a fresh SQLite in-memory database per test, overrides the DB dependency, and parametrizes over existing and non-existing users. FastAPI is async first. For testing async endpoints like streaming or background tasks, you need httpx, AsyncClient wired to your app through an ASGI transport. Here we test an async streaming endpoint. We use AsyncClient with an ASGI transport, and we verify that the response is actually streamed in multiple chunks. This is the same issue we highlighted at the start. Here's exactly why that happened. A dependency override was set in a test file but never cleared. When the next test file imported the same app instance, it inherited the override, causing the production root to return a fake database session. A separate integration test accidentally inserted data into that overridden session, and the connection leaked to the real database. A dependency overrides dict was set in a test file, but never cleared after the test module finished, causing cross-test pollution when the next test file imported the same app instance. The fix is to add a PyTest auto-use fixture that clears app dependency overrides before every test. Also, always use with TestClient app to trigger lifecycle events and ensure each test gets a fresh database session. This is the exact mistake from the incident. A dependency override was set but never cleared, causing subsequent tests to inherit a fake database session that eventually wrote to the real database. The article mentions async testing but doesn't show a reusable fixture. Use httpx, AsyncClient with ASGI transport to test async endpoints, streaming, and background tasks. This fixture ensures proper lifecycle and teardown. FastAPI 0.93 Plus deprecated at app, on event, startup, in favor of the Lifespan Context Manager. TestClient with block triggers both patterns, but if you use the new lifespan parameter, ensure your FastAPI version is greater or equals 0, 93. Older versions ignore the lifespan parameter and require the decorator. The article mentions background tasks, but doesn't show how to test them. Use background tasks and verify side effects synchronously after the request completes within the with block. To diagnose flaky tests, first check if dependency overrides are leaking by printing them in a teardown. Use PyTest xsetupshow to see fixture call order. For validation errors, inspect response, JSON, detail. Let's run through some common interview questions. What is the underlying technology of TestClient? It uses HTTPX with ASGI transport, bypassing network. How does app dependency overrides handle nested dependencies? It replaces the entire callable. Inner dependencies are not automatically resolved. How to test background tasks? They run synchronously within the with block, assert side effects immediately. And a few frequently asked questions. How to test authenticated endpoints? Override get current user with a lambda returning a test user. What database to use for tests? SQLite in memory for speed, test containers for PostgreSQL specific features. Why do tests pass in isolation but fail in suite? Likely leaking dependency overrides, add auto-use fixture to clear them. To recap, always use with TestClient app to trigger startup events. Clear dependency overrides in an auto-use fixture. Use SQLite in memory for database tests. Parametrize your tests to cover edge cases. And test your error handlers to ensure consistent response shapes. Ready to go deeper? Up next, FastAPI WebSockets, then FastAPI deployment, then FastAPI versus Flask versus Django. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.